So for problem 2 in this homework, you are given a function and you are asked to find the integration of that particular function. Because the function is a piecewise constant function, so it's easy to discuss if you were to plot the graph. Well, for this function, if it's less than -3, the graph is 0. If it's between -3 to -1, your function value is 3. Okay, you may want to spend some time specifying the boundaries, but it doesn't matter that much. And then -4, right, so starting from -1, go all the way up to 5, and then it's like that. So this is a graph of our function, and you are asked to find the first one is what's the integration from -3 through -4, f of t dt. And because your function from -3 to -4, it is the same as negative of -4 through -3, f of t dt, so it's going to be corresponding to the net area. But whenever my expression is less than -3, namely between -4 and -3, the value is 0, so what you're actually calculating in the expression looks like that, which is 0, right? So, well, I'll just demonstrate another point. So if I were to find what is g of -2, so you are trying to integrate from -3, and then plug in -2 on the top, f of t dt. And for this particular case, your function only has one value, which is at the height of 3. So this is what you're looking for. You can find the area by doing anti-derivative calculation and use fundamental theorem of calculus, or just think about the net area. So starting from -3 through -2, with a height of 3, this is the region you're calculating, so it has a height of 3, it has a base of 1, so it's supposed to be 3. So the calculation is actually relatively straightforward. Along the same line of thinking, let me demonstrate one more. So I'm going from -3 to 0, f of t dt. Okay, this is slightly trickier because going from -3 to -1, you have one function value, but after you go past -1, you have a different function value. So you have to split the function like this so as to carry out your integration. So for this case, you have -3, -1, the function value is 3, and then you add up to -1, 0, your function value now becomes -4, right? That's the height of it, dt. So you can either carry out integration or use the area. So it's base 2, height 3, it's a rectangular shape. It's base 1, height -4, so it's 6 minus 4, which is 2. So that's a net area. And if I were to plot it, it is basically this region where you carry out your integration, and then this region where you carry out your integration and you add them together. So you should be able to find g of 6 relatively easily. If I go up to 6, I can't really swipe through anything further. So it's this region, and then this region, two parts put together. Be a little bit careful about the sign. Everything below x-axis is supposed to be negative. The next question actually is not hard if you think about it. You're asking what's the absolute maximum value of g of x. G of x, if the x value were less than -3, the area is going to be 0. If the x value is somewhere between -3 and 1, so you are talking about an area somewhere here, the larger the x value is, the width becomes larger, the area becomes larger. However, once I go past -1, my height becomes negative, so the larger the x value is, the more negative pieces I will get, so my area becomes smaller because I'm adding extra negative pieces. Therefore, when I'm at the point of -1, that's the positive region reaches the largest, which is going to be my absolute largest function value. So it's going to happen when x is -1, and the area of this region has a height of 3, has a base of -3 through -1, which is a base of 2. So you can find the final region, which is the top part, to be as the largest value, which is 6.